Primary School Math Olympiad Challenge 2. This is a sample paper to help one prepare for the Primary School Math Olympiad. There are 30 questions. Challenge yourself to complete within 2 hours, please. If you can't achieve it the first time, do not be disheartened. With practice, one should be able to complete this challenge within 2 hours. If one works hard and revise this sample paper multiple times. Question 1. A test of 20 questions. 5 marks are given to the right answer. 2 marks are deducted for wrong answers. If John scored 65 marks, how many questions did he answer correctly? Question 2. If the equation of 301 and 2 over 3 is divided by 5 is equal to y plus 1 over 3, find the value of y. Question 3. Given that a plus b equals 15, a plus c equals 23, b plus c equals 28, what is the value of c plus c or 2c? Question 4. ABCD is a square. 4 smaller squares with side length of 1 to 4 of the square ABCD side length on each corner of the square ABCD. What is the ratio of the largest square that can be drawn in the non-shaded area versus the size of square ABCD? Question 5. Calculate the perimeter of diagram below, which is made up of 2 different sized squares with its area given as 117 centimeters squared. Question 6. The diagram comprises 2 identical right-angled triangles. AB is 20 centimeters, PY is 5 centimeters, ZQ is 5 centimeters, YA is 12 centimeters. Find the size of the shaded area. Question 7. The diagram comprises 2 equilateral triangles and the circle. If the area of the bigger triangle is 48 centimeters squared, find the area of the smaller shaded triangle. Question 8. 34962y36189271. What is the value of y in order the number is divisible by 9? Question 9. ABCD is a parallelogram with an area of 60 centimeters squared. BF to FC equals 2 to 1. Find the area of CEF in centimeters squared. Question 10. There are 1001 marbles in a bag. Jack and Joe play a game of picking up marbles from the bag. For each turn, they can pick 1, 2, 3, or 4 marbles from the bag. The last person to pick up the last marble will win the game. Jack will start first. How many marbles must Jack pick at the start in order to ensure he will win? Question 11. The equation 9 to the power of 15 is equal to 2, 0, 5, 8, 9, 1, x, 3, 2, 0, 9, 4, 6, 4, y. What is the value of x and y? Question 12. Find the simplest form of the equation. Question 13. There are 12 points evenly spread on the circle as shown. How many equilateral triangles can be formed by joining any of the 3 points? Question 14. The cost of magazines has increased by 10%, but the publisher decided to keep the selling price unchanged. As a result, the profit for each magazine decreased by 20%. In order to maintain the same profit for the year, what % of additional magazines need to be sold? Question 15. The table has 16 boxes. Only 3 of them are filled. If the sum of 4 consecutive numbers is the same and the total for all numbers is 1240, find the number in the last box. Question 16. That y is equal to y divided by the result of y minus the result of 2y minus 2 divided by 2. Question 17. Find the value of the equation. Question 18. The diagram comprises 2 similar-sized semicircles AFB and AED, with diameter AB and AD equals 6 cm respectively. ABC is a right-angled triangle with BC equals 12 centimeters. Find the size of the shaded area in centimeters square. Pi equals 22/7. Question 19. The time is after 9 a.m. The number 10 on the clock is right in between the hour hand and the minutes hand. What is the time? Express your answer in fraction. Question 20. The diagram comprises triangle ABC and 3 straight lines within the triangle AFDB and DF. Ratio of CF to FB is 1:2 and AE to F is 1:1. If the area of triangle ABC is 1 unit square, find the area of the shaded region. Question 21. What are the last 2 digits of the below equation? 206 to the power of 202. Question 22. A BCD is a regular pentagon with an area of 10 centimeters square. The area of ABC equals 2.76 centimeters square. Find the shaded area DFG in centimeters squared. Question 23. Y equals 5 to the power of A plus 7 to the power of B, where A and B are positive integers. What are the possible values of the last 2 digits of Y? Question 24. At the supermarket, Jack bought 5 bags of potatoes chips, 7 cans of sardines, and 1 can of tuna at a cost of $23.80. Mary bought 3 bags of potatoes chips, 4 cans of sardines, and 1 can of tuna at $15.10. Ryan bought 1 bag of potatoes chips, 1 can of sardines, and 1 can of tuna. How much did it cost Ryan? Question 25. The diagram comprises 2 squares, ABCD and HEFC. EF is 4 centimeters. Find the area of AHF. Question 26. What is the value of 3 to the power of 3, plus 3 to the power of 3, plus 3 to the power of 3, plus 9 to the power of 2, plus 81? Express your answer in value of 3 to the power of x. For example, 3 to the power of 10. Question 27. ABCD is a trapezium. ABFE is a rectangle with an area of 2,000 centimeters square. ABCD is divided by 99 parallel lines into 100 parts with same vertical height. If the largest part is 31.94 centimeters square, find the area of the ABCD. Question 28. A bag contains a mixture of red and blue marbles. John added 100 blue marbles into the bag. As a result, 1/3 of the marbles in the bag are now red. John added another 100 red marbles into the bag. The ratio of red marbles is now 3/7 of the marbles in the bag. Find the original ratio of red marbles in the bag. Question 29. What is the most and least number of Friday the 13th in a non-leap year? Question 30. Amy and Susan traveled from town A to town B, which are 24 kilometers apart. Amy started by cycling at the speed of 10 kilometers per hour, while Susan walked at 3 kilometers per hour. After a certain distance, Amy parked her bicycle at a kiosk and walked to town B at 4 kilometers per hour. Susan reached the kiosk, took the bicycle and cycled at 12 kilometers per hour to town B. Both Amy and Susan reached town B at the same time. How many minutes did Amy and Susan spend walking respectively? Answer for question 1. Full marks for getting all 20 questions correct is 100 marks. For each wrong answer, one would lose 5 plus 2 equals 7 marks of the 100 marks. John lost 100 minus 65 equals 35 marks. As such, John got 35 divided by 7, which is equal to 5 questions wrong. Thus John answered 15 questions correctly. Answer for question 2. 301 and 2/3 is also equal to 300 plus 5/3. Divide 300 plus 5 over 3, with 5, you have 60 plus 1 over 3. As such, the value of y equals 60. Answer for question 3. You will notice by taking away a and b from the combination of the equation 1 and equation 2 will give you 2c. The value of a plus b is given in equation 1. Thus, by deducting a plus b from the combination of equation 2 and 3 will give the value of 2c. Therefore 23 plus 28 minus 15 will give you the value of 36, which is the answer. Using this method, most children will be able to find the answer in less than 2 minutes. Answer for question 4. The largest square that can be drawn is the blue square. Add the two blue lines. From the diagram, one can see the ratio is 1 to 2. Answer for question 5. Since the area of the diagram is the sum of two squares, thus 117 should be the sum of two numbers which are squared of a number between 1 to 10, as listed on the screen. From the list of numbers, one could derive that 117 is equal to 36 plus 81, which equals 6 squared plus 9 squared. Thus the sides of the two squares are 6 and 9. We put them on the diagram on the right side. We add up all the sides, which give a total of 48, which is the perimeter of the diagram and the answer for the question. Answer for question 6. Add the dotted red line to connect y and z. Area of trapezium ABZY is equal to triangle ABC minus triangle YZC. As such, shaded area is equal to the area of trapezium ABZY. Area of trapezium ABZY is equal to 10 plus 20, then times 12 and divided by 2. The answer is 180 centimeters squared. Answer for question 7. Rotate the smaller triangle as shown in the second diagram. Notice the smaller triangle is 1/4 of the bigger triangle. Thus the area of the smaller shaded triangle equals 48 divided by 4. The answer is 12 centimeters squared. Answer for question 8. Sum of all digits in the number equals 64 plus y. Based on the divisibility rules, a number is divisible by 9 if the sum of its digits is divisible by 9. As such, 64 plus y is divisible by 9 if y equals 8. The answer is y equals 8. Answer for question 9. Add the dotted red lines. With the red lines, the diagram shows that the ratio of AE to EC equals 3 to 1, and BE to EF equals 3 to 1 too. As such, CEF equals 1/4 of BFC. And BFC equals 1/6 of ABCD equals 60 divided by 6, which gives a result of 10. Thus CEF equals 1/4 of 10. The answer is 2.5 centimeters squared. Answer for question 10. 1001 equals 200 times 5 plus 1. As such, Jack should pick up one marble in his first turn to ensure he win the game. For all subsequent turns, Jack should pick up the number of marbles equals 5 minus the number of marbles Joe picked up in his turn before Jack. Thus, for every subsequent turn, Jack ensures 5 marbles are picked up between him and Joe. As a result, Jack ensures there is at least one marble left for him in the last turn. Answer for question 11. Notice the last digit of the result of 9 to the power, repeat in sequence of 9 and 1. Given 15 is an odd number, thus y equals 9. The total of digits, 2, plus 0, plus 5, plus 8, plus 9, plus 1, plus x, plus 3, plus 2, plus 0, plus 9, plus 4, plus 6 plus 4 plus y is a number divisible by 9. Add up all the known digits, you have 53. Replace y with 9, you have 62 plus x. X is equal to 1 in order for 62 plus x to be divisible by 9. This gives a value of 63. Thus 9 to the power of 15 is equal to 2, 0, 5, 8, 9, 1, 1, 3, 2, 0, 9, 4, 6, 4, 9. Answer for question 12. Notice the numerator is a multiple of 1001 and the denominator is a multiple of 5005. Simplify both the numerator and denominator respectively. You have a numerator equals 1001 times the result of 1.0001 plus 10,001 plus 0.001 plus 0.01. Denominator equals 5005 times the result of 1.0001 plus 10,001 plus 0.001 plus 0.01. The terms of 1.0001 plus 10,001 plus 0.001 plus 0.01 in the numerator and denominator cancel out each other. The equation is now equals 1001 over 5005. The simplest form of the equation is 1 over 5. Answer for question 13. See the equilateral triangle form in the circle from point A. It is not possible to form more equilateral triangle with other points from point A, as their sides will not be equilateral. You can form 3 more equilateral triangles as shown. Thus the total equilateral triangles is 4. The formula to find the number of equilateral triangles is equals n divided by 3. As such, n needs to be a number of points divisible by 3. E.g., if there are 36 points, the number of equilateral triangles equals 36, divided by 3 equals 12. If there are 4, 8, 16, 20 points or a number not divisible by 3, it is not possible to form equilateral triangles. Answer for question 14. Let P equals original profit per magazine, then new profit per magazine equals 0.8 P. Let S equals original total sale of magazine. Let N equals new total sale of magazine, in order to maintain the original profit. Original profit equals original total sale times original profit per magazine equals PS. New profit equals new total sale of magazine times new profit per magazine equals 0.8 NP. In order to maintain the original profit, 0.8 NP need to be equal to PS. Solve the equation, N equals 1.25 S. Given N equals 1.25 S, thus the percent of additional magazine need to be sold equals 25%. Answer for question 15. Given a sum of 4 consecutive numbers must be the same, fill up others boxes where possible. Since the total of all numbers is 1240 and the boxes comprise 4 sets of 99, 77, 47 and Z. Thus 1240 divided 4 equals 99 plus 77 plus 47 plus Z. Work out the equation, the answer is Z equals 87. Answer for question 16. Work out the value of at 4, which is 4. Work out the value of at 3, which is 3. Work out the value of at 2, which is 2. Work out the value of at 1, which is 1. Work out the value of at 100, which is 100. Thus the value of the equation is at the sum of 1 to 100. Work out the equation, the value is at 5050. The result of at 5050 is 5050, which is the answer. Answer for question 17. Break up the denominators of the fractions in the equation, as shown. For example, 6 equals 2 times 3, 12 equals 3 times 4, 20 equals 4 times 5, and so on. Derive the equation further. For example, 1 over 2 times 3 is equal to 1 over 2 minus 1 over 3. 1 over 3 times 4 is equal to 1 over 3 minus 1 over 4. 1 over 4 times 5 is equal to 1 over 4 minus 1 over 5, and so on. The fractions cancel each other out, except for the first one and last one. Thus the remaining fraction is 1 over 2 minus 1 over 16. The answer for the equation is 7 over 16. Answer for question 18. Add the dotted red lines. Semicircle AF, B and AED overlap for the area surrounded by the dotted red lines. As such, the size of semicircle AF, B and AED minus the area surrounded by the dotted red lines is the same. Thus we can move the shaded area from within semicircle AFB to within semicircle AED. The shaded area, now the size of triangle ABC, equals 6 times 12 times half. The answer is 36 centimeters square. Answer for question 19. Let y be the angle between hour hand and number 10, and also the angle between minutes hand and number 10. 30 minus y then divided by 30 is the fraction of the hour hand movement after 9 a.m. and between 9 and 10. 300 plus y then divided by 360 is the fraction of minutes hand movement after 9 a.m. around the clock. 30 minus y then divided by 30 is equal to 300 plus y then divided by 360. Solve the equation. Y equals 60 over 13. The number of minutes past 9 a.m. equals 30 minus y then divided by 30 then times 60 equals 50 and 10 over 13 minutes. The time is 9, 50 and 10 over 13 a.m. Answer for question 20. Given the ratio of CF to FB is 1 to 2. Thus the area of triangle CAF equals 1/3 of triangle ABC. The shaded region equals triangle CAF minus triangle CDF. Given the ratio of CF to FB is 1 to 2, thus triangle CDF is 1/3 of triangle CDB. As such, triangle DFB equals 2 triangle CDF. Given the ratio of AE to F is 1 to 1, thus triangle DFB equals triangle DAB equals 2 triangle CDF. As a result, we have 5 triangle CDF equals triangle ABC. Therefore, triangle CDF equals 1/5 of triangle ABC. The shaded region equals triangle CAF minus triangle CDF equals 1 over 3 minus 1 over 5. The answer is 2 over 15 units square. Answer for question 21. Given that the digit 2 and digit 0 will not influence the last 2 digits of the equation, thus we will use only the digit 6 in all calculations. 6 to the power 1 is 6. 6 to the power of 2 is 36. 6 to the power to 3 is 116. The last 2 digits are 16. Let's focus on the last 2 digits only. Do not waste time on other digits as they are not needed to answer the question. Last 2 digits of 6 to the power of 4 is 96. Last 2 digits of 6 to the power of 5 is 76. Last 2 digits for 6 to the power of 6 is 56. Last 2 digits for 6 to the power of 7 is 36. Last 2 digits for 6 to the power of 8 is 16. You could see a pattern emerge for the last 2 digits. Except for the term 6, the last 2 digits repeat themselves every 5 terms. Given we are looking for the result a power of 202, we deduct 1 from 202 to account for the first term, 6, then divide it by 5. The result is 40, with remain of 1. Thus the last two digits of the equation is 36. Answer for question 22. Let's find the area of DEF first. ABC equals ACF equals CDE equals ADE. However, ADE overlaps CDE with an area size of DEF. As such, 4 times ABC minus the size of the pentagon ABCDE equals DEF. 4 times ABC equals 4 times 2.76. ABCDE equals 10. Work out the equation. You have DEF equals 1.04. Given DEF equals GDC, as such DFG equals ABC minus 2 times DEF. ABC equals 2.76. DEF equals 1.04. Work out the equation. The area of DFG is 0.68 centimeters square. Answer for question 23. 5 to the power of 1 equals 5, 5 to the power of 2 equals 25, 5 to the power of 3 equals 125. As such, the possible last two digits of 5 to the power of A equals 0, 5 and 25. 7 to the power of 1 equals 7, 7 to the power of 2 equals 49, 7 to the power of 3 equals 343, 7 to the power of 4 equals 2401. Without calculating the full answer, we know the last two digits of 7 to the power of 5 is 07. As such, the possible last two digits of 7 to the power of B equals 07, 49, 43 and 01. Build the table as shown. From the table we derived the possible last two digits of Y are 06, 12, 26, 32, 48, 54, 68 and 74. Answer for question 24. Hint: do not try to work out the cost of the individual item. For the ease of expressing the calculation in equations, let's label the potatoes chips as P, can of sardine as S, and can of tuna as T. 5P plus 7S plus 1T equals 23.80. This is equation 1. 3P plus 4S plus 1T equals 15.10. This is equation 2. Equation 2 times 2 equals 6p plus 8s plus 2t equals 30.20. This is equation 3. Equation 3 minus 2 give you 1p plus 1s plus 1t equals 30.2 minus 23.8. The answer is $6.40. Let's try another approach. Equation 2 minus 1 equals 2p plus 3s equals 23.80 minus 15.10 equals 8.70. This is equation 4. Equation 2 minus 4 equals 1p plus 1s plus 1t equals 15.10 minus 8.70. The answer is $6.40. Answer for question 25. Let the sides of ABCD equals Y. Area of AHF equals square ABCD plus square HEFC minus triangle ADF minus triangle ABH minus triangle HEF. Square ABCD equals Y square. Square HEFC equals 4 times 4 equals 16. Triangle ADF equals half times Y times the result of Y plus 4. Triangle ABH equals half times Y times the result of Y minus 4. Triangle HEF equals half of 4 times 4 equals 8. Work out the equation as shown. Area of AHF is 8 centimeters squared. Answer for question 26. Change the value of 9 to the power of 2 to 81. Both 81 are equal to 27 plus 27 plus 27. 27 is equal to 3 to the power 3. The equation is now equal to 9 times 3 to the power 3. 9 is equal to 3 to the power of 2. 3 to the power of 2 times 3 to the power of 3 is equal to 3 to the power of the sum of 2 and 3. Solve the equation. The answer is 3 to the power of 5. Answer for question 27. Let h be the height of a trapezium, A is length of DE, and B is length of FC. Let's label A plus B equals C. Area of ABCD equals size of the two triangles on the left and right plus size of ABFE equals half times h times c plus 2000 centimeters square. The largest part at the bottom of ABCD is 31.94 centimeters square, as shown by the red dotted line. The largest part within the rectangle ABFE equals 2000 divided by 100 equals 20 centimeters square. The largest part within the two triangles equals 31.94 minus 20 equals 11.94 centimeters square. As such, half times 0.01 h times the result of c plus 0.99 c equals 11.94. 0.01 h is the height of the largest part. C plus 0.99 c is the length of bottom and top base of the largest part within the two triangles. Work out the equation to find the value of half times h times c, which is the area of the two triangles. The result is 600. Thus the area of ABCD equals 600 plus 2000. The answer is 2600 centimeters square. Answer for question 28. Let R and B be the original red and blue marbles in the bag respectively. After adding 100 blue marbles, the ratio of red marble in the bag is R over total of R plus B plus 100 equals 1 over 3. Simplify the equation, you will have 2R minus 100 equals B. This is equation 1. After adding 100 red marbles, the ratio of red marble in the bag is R plus 100 over total of R plus B plus 100 equals 3 over 7. Simplify the equation, you will have 4R equals 3B minus 100. This is equation 2. Replace value of B from equation 1 into equation 2. Solve the equation, the result is R equals 200. Replacing the value of R into equation 1, the result is B equals 300. Thus the original ratio of red marble in the bag equals 200 over the sum of 200 and 300. The answer is 2 over 5. Answer for question 29. Create the table as shown. Row 3 is the number of weeks, and the remaining days in the month. For example, January has 31 days, thus it is 28, which is for 4 weeks, and remaining 3 days. In row 4, Y is a particular day of the week, when it is 13th of January. If Y is on Monday, then the 13th of February will be on Monday plus 3, which is Thursday. This is because there are 31 days between 13th of January and 13th of February, which is 4 weeks plus 3 days. If Y is Friday, then 13th of February will be Friday plus 3, which is Monday. As such, the most Friday the 13th in a year is when Y plus 3 is Friday, which are 3 occurrences. The least Friday the 13th in a year is when Y plus 1, Y plus 2, or Y plus 4 is Friday, which is 1 occurrence. Answer for question 30. For ease of understanding, draw the diagram on the right. Let Y be the point when Susan and Amy change their mode of travel. Since both reach town B at the same time. Time taken by Susan equals Y divided by 3, plus the result of 24 minus Y then divided by 12. Time taken by Amy equals Y divided 10, plus the result of 24 minus Y then divided by 4. Solve the equation. Y equals 10 kilometers. As such, Susan walked for 10 divided 3 equals 3 1/3 hours. The answer is 200 minutes. Amy walked for 14/4 equals 3.5 hours. The answer is 210 minutes. Thank you for watching. Please like and subscribe.